Good evening once again. This is Dr. Belga Berg, faculty member at Department of CSE, AI, ML and Cybersecurity, Jain deemed to be University. Welcome all to another session of Industry Connect program. Our resource person today is Mr. Debasish Hazra. Mr. Hazra has more than 23 years of experience in IT industry. He has worked with global MNCs like IBM, Ericsson, Kmeans Technology Solutions, and a US-based startup named Edzavelu Inc. in service areas like technology consulting, delivery leadership, crisis management, competency leadership, and mentoring. Mr. Hazra has a rich experience of handling clients across Asia Pacific, Europe, Middle East, and the USA. His expertise spans across a wide variety of areas such as data science, analytics, NLP, IoT, RPA, and CRM. Currently, Mr. Hazra is the head of data science at a US-based startup named Amplo Global Inc. Today, he will interact with you on the topic clustering and model validation. Welcome, Mr. Debashish. Please take over the session.
Thank you very much, Dr. Bark. Thanks for the introduction and very good evening to all of you. So there is no more introduction is needed. So absolutely my overall experience that has been already the brief has been given by Dr. Bark. So thank you very much once again. So all of you, without wasting any further time, quickly we'll get into the discussion. Before that, I hope all of you are doing well and staying safe. At least after 2.5 years almost, we are coming back to the normalcy. That is good, and probably your college or university has already been started. The class has been started, if I don't make a mistake. I'm not sure about Bangalore, how things are happening there, but probably most of the states and cities, they are coming back to normalcy. Okay, so let me share my screen. Is my screen visible?
No, sir.
Not yet. Okay. I hope now it's visible, right?
Yes, sir. Screen is visible. You will open in the slide somewhat, sir. It is actually not fully screen.
No, that I'm going to do that. Just I'd like to check whether it's visible or not. Okay. Okay. So today we are going. Yeah, thank you very much, Atinder. Thanks. So today our session is over clustering overview and evaluation. I believe, all of you, mostly of what I understood, students from second year AIML, so probably you are aware about clustering. But if it is not so, or if it is so, whatever it is the case, when we are going to discuss about clustering validation techniques, definitely to do the continuation, first of all, we need to give an overall briefing about clustering. So that is what my plan of doing so. So first of all, I will just give an overall briefing about clustering and different type of clusters quickly, and then we'll get into mostly concentrate on Kmeans clustering, how things are happening in Kmeans, and then finally we'll get into the evaluation and Pythonic implementation about it. So let's get into the agenda first. What we are going to do, first of all, clustering overview, if you can see, and then I will quickly explain about few of the popular industry use cases. Those are using clustering, and then clustering types, and then we'll get into understanding Kmeans clustering, and not only Kmeans clustering, but for other clustering also there are a few challenges. So that is what we are. Though the focus will be mostly on the Kmeans clustering. So the challenges of clustering, then we'll get into clustering model validation. What are the different kind of techniques? And finally, we'll get into Pythonic way of Kmeans implementation and cluster evaluation. Last 5 to 10 minutes, we'll have the question answer session. Let's see how things go ahead, and then accordingly we'll decide whether 5 minutes or 10 minutes for the question answer session. So make sense? Okay. So now, what is clustering? So clustering is nothing but a grouping of similar objects or data points. So clustering is a technique that happens that we apply for unsupervised learning. For supervised learning, we have the labeled data set, where for each and every observation, we have the target, we have the label. But in unsupervised learning, we don't have any label. That is for unlabeled data set. There is no question of classification. What we do the grouping of similar objects. So where more in each of the cluster itself, we group all different objects, and each grouping is termed as cluster. That is why it is termed as clustering. So objects within the same cluster should be very similar to each other with respect to their feature characteristics, and very different to the objects belong to other clusters. So what is that in synopsis? In each and every cluster, the compactness of the elements that should be high, the similarity should be high. It should be highly compacted, and the difference between the clusters, so the nature of the elements in different clusters, that should be highly dissimilar. Okay, so last point, if you see, this is intra-cluster similarity is high, but inter-cluster similarity is low. That is the whole purpose of clustering. So distinctly group the items, similar items. Okay, what is the difference between classification and clustering? Just quickly, I'm giving a kind of briefing. So for classification in the supervised learning itself, as I said, it is a target data set. So classification in supervised learning, basically it identifies based on the predefined classes, it does the training, and accordingly it predicts an unknown item based on the training data itself and based on the model from the supervised learning itself. That is what called classification. But there in clustering, there is no label data set, and therefore no question of clustering. So if you look into the right side data, so in this particular image, we have two different kind of cat images, and one is not cat. So you can consider it as a binary classification. So for supervised learning, if we do the training itself based on this cat versus non-cat data, and if I give a non-cat and other animal than cat, then it will predict whether it is cat or non-cat. But in clustering, this is not predictive. This is just if you give different items altogether, it will just group each of the items in a separate cluster. Okay, so I believe, this is a very basic kind of introduction. All of you know about it. Okay, so next one is very popular use cases in the clustering. What we do, the most popular one, everybody, nowadays, even during this COVID scenario, we are left going the mall or the multiplex itself. Mostly we watch movies in Netflix or Amazon Prime, this kind of through this kind of app, right? So when you use Netflix, you know the Netflix movie recommendation. Let's say you love to watch movie for certain actors like Shah Rukh Khan, like Amir Khan, like Amitabh Bachchan, or sometimes you love adventure movies, sometimes you love thrilling movie. So based on your choice, based on what you are watching using Netflix, so it keeps all the data based on the user ID, and whenever in your similar interest, what you like or what you have already gone through, you have watched that kind of movie, it recommends that kind of movie when you next time log into Netflix. So the Kmeans, the clustering mechanism that can be utilized, that is being utilized highly as a recommender system. Second is very popular use case is customer segmentation. So even though, let's say nowadays people most of the people we purchase items through e-commerce sites, let's say Amazon. So today you are just searching some item on the electronic product, like let's say a laptop. You are searching based on your budget, based on your certain criteria, or you are buying certain items under certain category. It could be medicine, it could be household items, it could be electronic items, it could be mobile gadget, whatever it is. So it keeps all the history itself, and not only what you have bought, but also it checks whatever you have shown your interest, the activity monitoring itself. There also what it does, it keeps all the records, right? And then accordingly, it segment the customers based on their buying history, interest on activity monitoring. So this is what called customer segmentation. This is also kind of grouping. So that is also clustering. Targeted marketing. Based on once the customer is segmented, then the targeted marketing based on the segmented customers, accordingly business can target advertising campaigns also. So basically not necessarily any kind of advertisement will attract me. So it observes, okay, this customer belongs to a certain segment. So this kind of marketing, campaigning, this belongs to this particular area where this customer belongs to. So that's how the targeted marketing and customer segmentation, these two are very much interrelated, and both the cases it utilizes the clustering. Semi-supervised learning, what is that? It is used for data annotation. Let's say in the real-time data, what happens? A lot of times, let's say you are getting huge amount of data. Data is coming from social media, data is coming from enterprise system, data is coming from anywhere, everywhere data we are getting. So sometimes what happens that in the same data set, for certain observations you have label, certain observation you don't have any label. That is unlabeled data points. So through semi-supervised learning, using the labeled data set, we can accordingly annotate the unlabeled data points also. That is where a lot of research work is going on already. People are working, and some of the cases already application is there, so that you can do the data annotation on unlabeled items based on the labeled data set in the same data group. Then anomaly detection. Anomaly, everywhere there could be anomaly or fraud. It could be in the telecom industry, it could be in the banking industry, it could be anywhere. Fraud could be in the network traffic, everywhere. So wherever there is any anomaly, let's say there is an audit that is going on for certain institution. So there are huge number of data. So there, where is the anomaly, that can be also grouped together using this clustering. Okay, so and then call record detail. So using the CDR analysis, let's say, based on your voice call, SMS, internet activity, everything is tracked in the call record detail in the telecom service provider. So based on the CDR data, also if there is any kind of anomaly that is therefore, or certain behavior, there is certain issue with the behavior, the way customer is. And if you look into the call record detail, it is not only anomaly. Based on the usage, you can even find out if there is a chance of attrition for a particular customer, right? So churning, so customer can churned out. Let's say I'm not happy with certain service provider, and that is why I have reduced using the service from that particular service provider because of any XYZ reason, and that can be also, this kind of grouping is also possible. So grouping, clustering is useful everywhere itself. Okay, so next we are moving into types of clustering. So types of clustering, there is hard clustering and soft clustering. From the right side picture, it is self-explanatory. Hard clustering, basically there is no overlapping. One observation can be there, can belong to only one cluster, not more than one cluster. But in soft clustering, there is a probability of overlapping also. So one point, let's say for an example, one item could, which is the kind of feature it has, it partially meet up the feature of the element that belongs to cluster A, and actually some of the cases the feature is also related to the feature of elements in cluster B. So basically it is a overlapping. So it's exactly cannot identify where it will belong to exact, I mean in the exact clustering. So it is a kind of overlapping itself. And with respect to algorithm types, there are different kind of algorithm: partitional clustering, hierarchical clustering, density-based clustering, grid-based clustering, model-based clustering. I am not getting into much detail into that because that will be out of scope for this today's session. Just to give the so K-means clustering, that comes under partition clustering, and K-means, K-mediots, and K-modes. These are the most important kind of algorithm under partitional clustering. For density-based clustering, mostly it is dbScan. For hierarchical clustering, agnos, that is very kind of, I mean, popular kind of, I mean, algorithm. So next we'll get into understanding K-means clustering. So now onwards, mostly we'll focus upon clustering technique, challenges, evaluation, and Pythonic way of implementation using K-means. Okay. So what is K-means clustering? So in the K-means clustering, first of all, what I will just look into the points. I am just getting into the points, and then I will give you a demonstration which will be easier for you, all of you, to understand what is actually K-means clustering, how does it do the cluster, and what is the disadvantage even for K-means clustering. So what happens, let's say you have two-dimensional data. You know, I mean, if you plot the data in the scatter plot, based on the nature of the data, randomness of the data, and the grouping of the data, you can sometimes it may be possible for us to visualize, okay, there could be 2 clusters, 3 clusters, something like that. But where the number of dimension for each of the observation, number of dimension, it is very high, right? Significantly high, or it is even more than 2 also. So there it is difficult to visualize that kind of data I mean, plotting into a scatter plot and then accordingly find out the number of clusters, not find out, just assume the number of clusters. So that is one of the disadvantage also. So first of all, if you are not able to plot the data and visualize the data set exactly, then also you need to identify, you need to just give a random number of cluster to start with K-means. So decide number of clusters manually, and then what you need to do, we need to randomly, let's say you have 2 sets of data, clearly you can distinct it. Just I'm giving you just for an example. So you can decide, okay, there will be 2 clusters. So randomly you need to place the centroid. What will happen after you put the centroid in the clusters? You don't know anything about the data. We don't know where to put the centroid, but you are just placing the centroid randomly. So decide, so what it will do, all the points in the data set, all the observation points, they will calculate the distance between each of the point and each of the centroid. So each point will measure the distance from each of the centroid, and which is the, and the distance could be Euclidean, the distance could be Manhattan distance, whatever it is. So, but the distance, which is the minimum distance, accordingly, that point will assign itself to that particular centroid. So this is called assignment. So once the centroid, and initially what centroid we are assigning, that is called seed centroid. Seed centroid. So it will assign for the first time towards the seed centroid. So once it is done for each of the observation, and it will be assigned automatically to the nearest centroid, then what will happen? Look into the point number 5 itself. So once the assignment it is done, then next step is it will calculate the mean coordinate for all the elements. So let's say for cluster C1, you have 2 points, A and B. A has point x1, y1, B is x2, y2. So the mean of X, point A and B, it is x1 plus x2 by 2. And mean of Y is y1 plus y2 by 2. So now the C1 cluster will move to that new position based on the mean coordinate. So accordingly, it will happen for each of the centroid itself. So now the centroid moves. Once the centroid moves, again, each of the element will calculate the distance and find out the nearest centroid and assign itself to that centroid itself. So this is the step 4 and step 5. This is the repetitive step. So once the assignment it is done, then one step is iteration is complete. Again, the cluster centroid will move, and accordingly, it is a typo. It is not move clustered. It should be move centroid. So the centroid will move, and accordingly, the elements will be assigned. So this repetitive step will continue till there will not be further changes. Now, it will be easier for you to understand. Now, I am going to demonstrate one thing from this particular site. It is very useful site. You can also utilize it for your practice. You will understand what Kmeans actually, how does it do and what is the disadvantage. Let's say how to pick the initial centroids. As I said, first of all, you need to decide how many centroids. So let's say first of all, I will choose. And what is the kind of data set you are looking into? Let's say it is Gaussian mixture. So this is the Gaussian mixture data set. Okay. Now, since I have chosen manual, so centroid, so I'll just put the centroid, let's say here, and see the changes of color where I am just assigning, and it is not assigned, I'm just placing the centroid. Okay. So now randomly I have placed the centroids. I don't know anything about the data. Okay. So once the centroid is placed, when I click on go, actually the nearest points to that centroid will assign itself to the other respective centroid. Now, let's say nearest to the green one, the points will be marked as green. Nearest to the blue, it will be marked as blue, and nearest to the red, it will be marked as red. Okay. Now, that's the one iteration is over. Now, the next iteration, what will happen? So now, what I said, once the assignment is over, again, each of the point will calculate the distance from the nearest centroid itself. So each of the centroid, and wherever it is, which is the nearest one, so it will move accordingly to the respective centroid. So again, when I update the centroid, and what will happen? The centroid will first of all move to the mean of the coordinates. So for each of, let's say for the green one, so it will take x coordinates. If it is two-dimensional data, then it will x coordinate for all the points divided by number of points, and y coordinates for all the points divided by number of points. So that is the x and y coordinate, new xy coordinate for the centroid, and accordingly the green centroid will move to that place. The same thing will happen for these two centroids also. So update centroids. See the movement of the centroid. Okay, centroid has been moved. Now again assign the points. Okay. So I can see there is no further changes in the assignment. That means this is we have already achieved the optimum level clustering. Okay. Now you see, when for the same data set I have given the cluster centroid like this, that is how it has done the clustering. I'll do it once more. Let's say I will do it now. In different places, the centroid. Okay, let's say here it is, and here it is. Go. So assigned. Again, update centroids. Again, reassign. Is done. Now I'll go to the randomly. Add centroid. Add centroid. Add centroid. Okay, go, update, again reassign, update. See, slowly the centroid is moving towards the blue points. Okay, and now the red ones will come, you will change to blue. Update, reassign. So what will happen? So basically it depends what happens for most of the cases, sorry. So the challenge is that, first of all, you need to decide the number of cluster, and based on the number of the initial centroid position, where you are placing your centroid, the seed centroid initially, based on that actually depends how the final cluster output will come. For the same set of data set, for the same number of cluster, only for the difference in the seed cluster positioning, the cluster could be different. So that is another challenge. Okay. And sklearn, basically it gives this has the Kmeans, I mean, it has a package called Kmeans. You need to import this library from the sklearn package, and here is the syntax. So if you see, the in cluster equals to 8, that is by default. If you don't mention any cluster number, so by default it will take in cluster eight clusters. So what is, I'm just discussing about the important parameters that is mandatory to understand. So in max tier, so I told you, so assignment and centroid movement, this is a repetitive step. So once the centroid is moved, element has been assigned to the nearest centroid. That is one iteration. So for that, so by default, the maximum iteration where the clustering will finally converge, the Kmeans will converge. So that is given 300. You can modify this data. You can give more than this. You can give, normally it happens below, much below 300. Finally it converges, but you can change the data in any ways. N init equals to 10. This is a very important one. As I said, for different positioning of seed cluster, the cluster output could be different. So that is why what you need to do, you need to, for the same number of clusters, what happens, the sklearn automatically, based on the value you are supplying here, n init, it assigns the initial centroid this many number of times for each cluster number. So for cluster 1 in clusters 8 itself, it will 10 times it will run with 10 initial seed. Okay, so for each of the, because otherwise what will happen, and it will return the best output from that particular result. So for each of the cluster, so for one initial seed, it will give an output after running 300 or the maximum number of iterations. Let's say another initialization is done, again it will give give the output. So finally the best output it will give you as an best one, it will give you as an output. So that is why you need to specify n init as well as max tier and the n cluster. These are the major these are the most important parameters that you need to remember. And also this one is also important, Kmeans ++. So if you look into, go to sklearn page itself, in Kmeans you have the explanation for each of the parameters. So Kmeans ++, if you give, it actually converges the Kmeans very faster way. Okay. So now get into the challenges, what I have already told you. So different centroid initialization concludes with different set of clusters for the same K value and same data set. You can experiment it to the site what I have shown. So everything you can experiment with different set of data, with different number of clusters, with different type of seed. It could be random or it could be manual. So that's how you can test it itself. Number of clusters, K value needs to be selected manually, and no ground truth data. So what is the solution? So for Kmeans clustering, or for any kind of clustering, you normally what happens, we should validate the business insight, because clustering doesn't make sense unless each of the grouping gives some intrinsic value itself, the business insight, what is the data inside. If you don't understand the grouping, just for the sake of grouping, there's no point of grouping. We need to understand the data inside, why it is, what this grouping actually is interpreted to. So what is the data inside we have come across through this grouping. Okay. Solution is another is various iterations is required with different centroid seeds. That is what it is in it. I have told you. need to run the algorithm for different number of clusters and find the best number through validation technique, which I will showcase you. Compare between different clustering algorithms outputs. So don't rely upon only one algorithm. You can do it through multiple algorithm, and then you can compare the result between different algorithms. And pre-processing, that is one of, like any supervised or unsupervised learning methodology, you have to do the pre-processing, because pre-processing, there are many steps, but outlier removal and standardization, data standardization, that is most important steps during pre-processing of data, and that is required here also, because Kmeans cannot work with outliers. Okay. Next, we are getting into the clustering technique. So now let's say the data is given to you, but you don't know whether you should cluster the data, whether the data has the clustering tendency at all. Just for the, if you give any data, even which is no way you can cluster, right? There also, if you just apply the clustering technique, it will give you the cluster, but that doesn't make sense. That doesn't make sense, because clustering makes sense. So technically clustering will happen, but it will not give you any meaningful result, meaningful data insight. So first of all, what you should do by having the data, if you feel that clustering is clustering we need to do, you need to measure what is the clustering tendency. Can you cluster this data? So that is, then you need to apply the clustering. So measure clustering tendency. That is one of the most important step, initial step. And clustering tendency we can measure using Hopkins statistics or VAT or IVAT, virtual assessment for testing, or improved virtual assessment for testing. We'll come across this quickly. And next is external indices. So this is measuring clustering tendency before doing the clustering. External indices, this is after getting the result from the clustering itself. Once the clustering is done, you can compare that data set, the result, with your external reference. So external reference means, let's say even you can compare it with the labeled data. So most of the cases, clustering is applicable for unsupervised learning. How come this labeled data is coming into picture? Yes, I told you already. There could be certain cases where the label is not there. So data annotation, it could be, or there could be another scenario where you'd like to test your algorithm, Kmeans or whatever clustering algorithm, but you don't know how much it is effective. So what you can do, you have a label data set, you just eliminate the target, you eliminate the label, and then you apply your clustering on that data set itself, and then you validate with your label data set. So that's how we can do that is called external indices. So under external indices, there is different mechanism called entropy, purity, Rand index, Jaccard coefficient. There's a different scenario, but what I will explain quickly about entropy and purity, how we can utilize for external indices and what is the Pythonic way. And this is a very simple thing. Even you don't use Pythonic, that also you can do it easily. And then internal indices. Once you have done the clustering without any external references within the cluster, using the cluster itself without utilizing any external reference, you can evaluate the cluster quality. So that is termed as cohesion and separation. Cohesion and separation. And cohesion, what is cohesion? As cohesion is the compactness of data in individual cluster. So what is the level of similarity? What is the level of compactness of elements in a particular cluster? That is called cohesion. And what is separation? How much the elements clusters are different to than each other. So element in cluster A, element in cluster B should be highly dissimilar. So that is the separation. We calculate the cohesion and separation. We can understand what is the quality of cluster. And the last one, last but not the least, determine. There are other mechanisms also, but for within 1 hour session, this is what I am going to cover. Determine optimal number of clusters. So as we are hypothetically taking the number of clusters, as you have seen for Kmeans clustering, you don't know whether you are right or wrong. So you need to find out finally which is the optimal number of clusters actually. Okay, we are going to showcase this. Okay, now clustering tendency. As I said, initial, that is the Hopkins statistics. Hopkins statistics is you can implement, just concentrate on the coding part. You need to install PyClusterent, this package, pip install PyClusterent, and under that, from that you need to import Hopkins. And this is sklearn I have used just to utilize the iris dataset and pre-processing scaling. As I said, removal outlier and scaling, that is very much important for any kind of clustering itself, right? So now, and one more important point, you should not apply clustering tendency on the entire data set. You need to take a sample and then you apply it, because just you need to understand what is the nature of data, whether clustering you can apply on that or not. So clustering, for measuring the clustering tendency, you don't need to take the entire data set. So we have considered just 150 observations from X, and the data record is that is 0.186. So what I have mentioned here. So for Hopkins statistics, the age value, what we are getting Hopkins value, if in between it lies between 0 to 0.5 for non-homogeneous data. So if the data lies between 0 to 0.5, that means the data is non-homogeneous and clustering, it has the clustering tendency. And if the age value is nearby 0, that means it is highly clustered data set. But if the age value is greater than 0.5 and less than 1, then data is uniformly distributed mostly. So homogeneous, and possibility of clustering is unlikely. So that is one measure, you can say. What is the next measure? That is VAT or IVAT. This is a visualization technique. That is why it is termed, this is termed as what I said, visual assessment for testing, or improved visual assessment for testing. So you can visualize the data. So here also the VAT or IVAT you can import from PyClusterent package itself. And if you load the data set and find out the IVAT or data, what is happening actually, the most prominent part, square box diagonally, that is giving the number of clusters. And sometimes it is within clusters, there is subclusters. So at least it gives you, and if you for certain data set, you cannot have this kind of prominent boxes, right? So basically, if you see, the VAT IVAT detects the clustering tendency in a visual form by counting the number of square-shaped dark blocks along the diagonal in a VAT image. So these techniques should be utilized initially to understand the clustering tendency. Next, we are getting into the use external indices. You are comparing the data. So entropy and purity, I'm not sure whether you are aware about this term entropy. If you have gone through decision tree or other algorithm, mostly it is used in decision tree for information gathering. So entropy probably you have used. If not, just quickly, I'm giving an example. Entropy is basically what is the level of uncertainty. Let's say you are just flipping a coin. For a magic coin, most of the times, if it is just coming to head, not tail, so most of the times, so that means there it is very much certain. So less the entropy value, less the uncertainty, and better the clustering. So entropy and purity. And what is purity? Let's say you have 22 karat gold, 24 karat gold, or you are prepared anything in the manufacturing plant. We build we produce the item based on certain raw materials. So we would like to understand what is the purity. So the concept of purity here in the clustering, that is also similar. So what is entropy and purity? That both for this entropy and purity, you need to know the class of that data observation. And if you know the class, then accordingly the class will be allotted to the respective cluster. So that is why it is termed as external reference. You have the external reference. That means you know the class of the data. So both entropy and purity is clustering external evaluation, and this is why it is termed as supervised evaluation clustering, because you know that level of the data. So you are utilizing that level to do the clustering level, right? What is the level for that clustering? And label data is needed for such evaluation. So more the purity, more the cluster reliability, and less the entropy value. That means less the uncertainty. Okay, so more the entropy value, most uncertainties. So less the entropy value, better the clustering. So what is the calculation of entropy? Entropy calculation is nothing, complex. It is very simple. For each of the clustering, actually, what you need to do for each of the cluster, you need to find out the probability. Rather than giving this particular formula, let me get into the example straight away so that it will be easier for you to understand. Okay, so let's say you have three different, after clustering, you got cluster 1, cluster 2, and cluster 3 in the right side picture. You just look into that. In the cluster 1, you have 5 red points and 1 blue points. So if you compare it in the table itself, in the tabular form, what I have done, that for cluster 1, 5 red, 1 blue, 0 green. So similarly for cluster 2, 1 red, 4 blue, 1 green, and cluster 3, 2 red, no blue, 3 green. So entropy means what is the where we can do the entropy, where you know the class actually. So basically what is happening in cluster 1, cluster 2, and cluster 3, if you know the already the level of the class elements, so accordingly you will just mark those clusters with that particular level. Now what is the entropy? Entropy you need to calculate in this way. You need to take the probability. So for red, the probability, what is the red probability for cluster 1? 5 by 6. What is the blue probability? It is 1 by 6. What is the green probability? 0 by 6. Similarly for PK2, it is for cluster 2. 1 by 6 is red, 4 by 6 is blue, 1 by 6 is green. And for third cluster, it is red is 2 by 5, total number of item are 5. So 0 by 5 and 3 by 5 is for green. So you need to consider, you need to calculate the probability for each of the element in that particular cluster. Okay. Now, what you need to do, what is the formula? Now you go back to the formula. Formula is for each of the point, what you need to do, you need to calculate the probability multiplied log of that probability to the base 2. You need to do it for each of the point and you need to sum up. So what we are doing here, you can do it using Python also. You can do it manually if the calculation is very simple, but if it is not so, you can use Pythonic way also. What you need to do, you need to import entropy from skippy.stats. What you need to supply in the entropy, you need to calculate the probability, and then you just give as an input parameter for entropy cluster 1. What is the probability? 5 by 6, 1 by 6, 0 by 6 to the base 2. It will calculate the cluster entropy. What is that? Cluster 1 entropy is 65%. Similarly, for cluster 2 entropy, it is 1.25. Cluster 3 entropy, it is 0.97. Now, the impurity. Impurity is more simpler. Impurity, what is that? You need to calculate the probability for each element in each of the cluster. And you need to take the maximum one. So let's say for cluster 1, 5 by 6, 1 by 6, 0 by 6. Which is the maximum one? 5 by 6, obviously. Okay. So for cluster 1, purity is PK probability. It is very simple. I mean, we don't need to explain. And purity for cluster 2, it is PK2, and purity for cluster 3, it is PK3. Okay. So total purity, how you can do that? So, sorry, I forgot to mention the total entropy. So for cluster wise, we have calculated the entropy from the formula. So total entropy, how do you need to calculate? For cluster 1, what is that? For the 6 by 17, total number of points in cluster 1 divided by total number of points across all the clusters. So if I calculate it, 6 and 5, 17 points. So 6 by 17 into cluster 1 entropy. Then cluster 2 is also 6 by 17 cluster 2 entropy, and then 5 items there in cluster 3 plus 5 by 17 into cluster 3 entropy, that is 0.97. So this is the total entropy for this cluster, all these 3 clusters. And what is the total purity? Similar exercise. So for each of the cluster purity, you have already identified by maximum probability, and then you multiply it with the individual clusters total element probability. This is a total number 6 by 17. 6 by 17 into purity of cluster 1, 6 by 17 purity of cluster 2, 5 by 17 purity of cluster 3. So total purity is this. So what is happening? So you can see this, for this cluster purity is 70%. So more higher the purity, good the cluster. Lower the entropy, less the uncertainty, good the cluster. So for cluster 1 entropy, we can see it is 65%. So out of these 3 cluster 1 is the most quality and compact cluster itself. Okay, so this is with respect to the external reference. So now with respect to the internal reference, cohesion and separation, as I said. So cohesion is the compactness of the elements for each of the cluster elements. Okay, so measure the compactness and degree of similarity. Cohesion, basically it gives the degree of similarity. What you need to do, you need to sum of squared error. So calculate mean value or centroid of all the points within the same cluster. What you need to do, you need to calculate the mean value or centroid of all the points within the same cluster, and then you need to measure the variance of each point in the cluster to the calculated mean. Okay, so I will do the exercise. It will be easier for you to understand. And separation is what it is. Separation is the dissimilarity at inter-cluster level. What we are doing? We are doing the calculating the mean value or centroid for every cluster, and then measure. So for, let's say, for, okay, let's get into. We will explain Silote coefficient later on. If we have time, this is a very important but is very complicated one, and it is very much useful to understand cohesion and separation both, and very much popular in the industry, right? But this is a very complicated one. If we have time, we will discuss, otherwise not. So let's concentrate on the Pythonic way of Kmeans implementation. If we give the entire study on this particular part, I mean, what I am going to do using Python, it will give you the clear understanding about the Kmeans, how it is happening, what is the optimal number of clusters, and visualize original points and clusters, cluster cohesion and separation. So let's focus on that. This is the last part. Okay, so now what am I going to do? I'm going to open my Jupyter notebook. Okay. So what we have done, we have just taken some points, hard-coded points, what you can do, and this is only 15 observations we have considered. But if you would like to do with more random data, that also you can create the random data. You can generate the random data using blob, right? So that you can do. But the next mechanism, just generating the data, you can do it using random. But the next what we are going to learn here, that is same. Okay. So these are the number of observation, x coordinates this, y coordinates. So these two are different features. Okay. So what I have done, z features, it is actually just I am tupling. So okay, 1, 4, 1 and 4, 2.22. That's how actually we are doing it. Okay. So what we are doing from this particular points, we are first, what we are doing, standardizing it, standard scalar. Okay. So what we are doing, so that there is no variance. You know, I believe you know what is the need of standardization. I mean, what is the need of it in machine learning? Why you need to do it? That you know. This is my assumption. So you need to standardize the data, and then you need to plot the data up to this point. So what we need to do, we are plotting the data. Plotting is nothing in the scatter plot. Just we are plotting the entire set of data. Okay, so these are the after standardization, this is the set of 15 observations, x and y axis. Okay, 2 features, and we are plotting it in the scatter plot. Now the actual story comes. So what we are doing, if you remember, in the sklearn K-means clustering, we have shown, we have already explained n in it. What it is? It is the 10 initial seed centroid. So so that it gives us the best result. There is a lot of variance. If I consider only one seed centroid, initial centroid, so it will consider the initial centroid 10 times, max tier 300. So we are giving all the parameters here. Okay, and now rather than considering any particular cluster number of clusters, we are considering the cluster for 1 to 11. Let's say you can whatever number you can do, but just let's say 1 to 11. What will happen for each, let's say initial first loop, it will take one cluster only, consider one cluster for the entire data set, and it will take all the parameters and it will fit the data. Scaled features is the data where we have done the scaling. Scaled features, it will take the data, it will fit it here, and then in the Kmeans inertia, what it is? Inertia is one of the parameter in Kmeans, and another parameter is you will see the labels. Okay, so in the Kmeans inertia, it will take it will append the entire value, how basically the SSE, I mean this value is being stored in Kmeans inertia. What is going to happen? So why we are storing it into SSE.append Kmeans inertia? SSE just initialize, we have done the initialization. So in the inertia, this graph, number of clusters versus SSE. Okay, so we are doing this graph. What we are doing, for each of the number of cluster, we are storing this inertia value for that particular number of clusters. For one, it will be it will store the value up to 11. For all the values it will store, and then we are plotting the data. Now if you look into this elbow, you see the more the number of clusters, less the SSE. But even though it converges near 10, but where the elbow it could be 2, elbow it could be 3, but mostly it looks like 2, right? Or it could be 3. We don't know where it is exactly. So let's say what you can, by visual interpretation, you can consider 3 as elbow, but what you should do, programmatically you can do that. And for that, what you can do, you can import from need, you can import knee locator. Need, you need to install pip install need. Okay, and then you need to import knee locator from need. This is a very important one, which you need to calculate automatically the elbow. So what I have done here, I have done kl dot equals in knee locator range 1 to 11, SSE curve convex and direction decreasing. Okay, so now what is the optimal cluster number? So after you initialize this one, so kl dot elbow is the attribute at elbow is the attribute for knee locator. So automatically it will give you the elbow value. So now it is throwing the value 3. So basically 3 is the elbow, not 2. So by visual interpretation, you don't need to do it. You do it programmatically. What is happening now? Again, I am running the cluster, but this time I am taking this cluster number 3 here. Because initially I have considered all the cluster numbers and we have checked it. Now we have seen the most optimal cluster is 3. So now again we'll run the cluster. So Kmeans we have already now we are running with number of clusters 3, max tier same value, init and random state 42. Okay. What is happening after fitting this data? You labels underscore Kmeans.labels underscore, where basically when you are it will assign the label against each observation. Against each observation, it will assign the labels. Okay, so Kmeans underscore labels, all for I have 15 observation here. Also you have the 15 labels, but distinct level is 3, 0, 1 and 2. Okay, so I have found out the unique labels. This is 0, 1, 2. Cluster centers, it is another attribute of Kmeans. It will identify after doing giving the output of all the clusters. You can find out what are the cluster centers against each of the cluster. So this is Kmeans.clusters underscore centers. What I have done, I have placed all the points with the respective colors, and I have placed the centroid also here. Okay, so that's how you can do the Kmeans clustering. Now, we have already validated the optimal number of cluster. One validation we have done. Still, we have not done the internal incidence. Okay, so indices, internal indices we have not yet done. That is the separation and cohesion. So that we are going to do right now. Okay, so what we are doing, we are placing the entire data, okay, first of all in the dictionary and then in the pandas data frame. Why I have done it in the pandas data frame? Because the calculation, manipulation of data, that is very much easy if we do it in the pandas data set. So the entire data what you had, we have put it in the pandas data frame. And also in the dictionary, if you see point x1 to x15, okay, so point x1 to x15, these are the point name, and x is, what is x? X is basically the entire, x is the entire set of value here, and y is the entire set of value here. So we have plotted the entire and all the features and clusters, labels. So labels we have identified here itself, labels, all the labels. So we have marked this column also here in the dictionary. So for each observation, now you know what is the label, cluster label. Okay. Now, if you remember, I have said while you will go for either go for cohesion or calculate separation, you need to find out the mean. You need to find out the mean coordinate itself, right? So what is the mean coordinate here? Now the centroids dictionary, I have given the x. X, what is the x? For CS cluster unique levels 0. That means wherever you have the 0 unique level from this particular dictionary, okay, so wherever it is having the value 0, you take the x value there. Okay, so for 0, let's say for 2, let's say for 2, you have one observation 1, one observation 2.2, one observation is 2.35. So what we'll do, you will take the mean of these three. Okay, so 1 plus 2.2 plus 2.5 by 3. Okay, that is the mean. Okay, and another for cluster, and what is for level 1, the x coordinate, this is unique levels 1. That means it will identify the mean of it will identify the x coordinate wherever the level is 1, and it will find out the mean, and same for 0 also. So in the first one, what it is doing, it is find out the x coordinate for all the clusters, and similarly it will find out the y coordinates for all the clusters. Okay, this is a self-explanatory. Probably it is becoming a bit difficult for you since we are doing it very fast, but for the interest of time we need to do it. So you will find out the cluster. What is this cluster? X and y. This is the mean coordinate. Okay, once you have the mean coordinate, how you will calculate the cohesion? So cohesion basically, so mean coordinate you can find out here. So for index row in CS cluster 0 ITR rows, now we'll find out for cluster 0, wherever in the pandas data frame the cluster is 0, we'll identify all the observations, and from ITR rows what we'll do, we'll take the x value, row.x, and what we are going to do from row.x to the mean distance. Okay, so this is, we are calculating the distance basically. Okay, so a coordinate, geometry itself, nothing more than that, Euclidean distance, x2 minus x1 whole square plus y2 minus y1 whole square, right? And root over, square root of that. So np dot square root, observation point x value, where the cluster 0, you have found that x value minus whole square plus the y coordinate, similarly we are taking. So for each of the observation, we are taking the distance from the mean and we are adding it, summing up. So cohesion underscore 0 plus equals to. So for cluster cluster 0, we are calculating the total cohesion. Total cohesion. So basically, what is this? So all the entire variance, it is actually the variance. If you consider, you are considering the mean distance from its mean. Okay, so you are considering the variance. So you are considering the variance once that is why I said the more so where the you are calculating the cohesion. So now what you are going to do it after adding the entire cohesion, you will just make it average. Okay, so number of items you have there. Okay, so in the question 0, the summation what you are taking for each of the point element toward to the mean distance, mean point itself, you are calculating the distance, and then question equals to the entire addition divided by number of points you have. That is it. Okay, that is the question. So if you go to that, okay. So similarly, what you will do, you will do the calculation for question, cluster 1 and for cluster 0 also. Okay, cluster 1 and cluster 2 also. So for all the clusters, you need to calculate the cohesion. So that's how the cohesion of cluster it is. We are getting the values 0.66, 0.66, 1.01. Okay. Now what we are going to do, calculate the separation, that is the dissimilarity between groups. What we said, you have the mean coordinate already for each of the cluster. Now from one cluster mean, okay, so what you are doing, so np dot square root, let's say the x value you are doing the centroids. Okay. So for the one cluster to another cluster mean value you are taking. Okay, so whichever is cluster 1, cluster 0, cluster 1, cluster 2, it is the distance between cluster 0 and 1. Now you will need to calculate cluster 0 and cluster 2. What you are calculating between the mean values. All the clusters have their mean value. Okay, so the centroid, you are finding out the distance between the centroids. So for 0, you need to find out the distance between cluster 0 and 1, and the distance between cluster 0 and 2. And then actually what is the separation of cluster 0? This is distance from 0 to 1 plus distance from 0 to 2, addition, summation, and then average divided by 2. So that's how you will calculate the separation of each cluster. So for the cohesion, you need to measure the distance for each of the point within the same cluster between each of the point and the mean value of that particular cluster. But for separation, you need to calculate the distance between the centroids of two different clusters, right? And then you need to average, and that's how you will calculate the separation. So now if I plot it in the pandas data frame again, you can see cluster 0 have a cohesion of 0.666 blah blah separation. So that is what we said. The more less the cohesion, the more the compactness, more the separation. That means more the dissimilarity between two clusters, and that is what is our goal. So that is what I can say. It is the cohesion and separation. That's how you can also validate. So we have covered up all the validation technique except the Celote coefficient. So Celote coefficient, it is probably we are running out of time. What time? I mean, do we have any further time? 5 minutes. Can we bear up with question?
Yes, sir. You can take 5 minutes. Yeah.
So I have covered up all the items that I have already said at the beginning of the session. So all the Pythonic way we have covered up, and cohesion, separation, except Celote coefficient. Everything we have covered, entropy, purity, everything, and all the Pythonic way of implementation also we have covered. That's all. So okay, so now the stage is open for questions. So we can have 5 minutes probably for the question answer session. So if you have any question, please feel free to ask me. You don't have any question probably, right?
Okay, sir, if we don't have questions, shall we wind up, or do you have anything more to add to what you have
No,
said?
I mean, that's all probably. Just I would like to mention one thing here, that for clustering itself, it's a very I mean, you need to make a lot of practice itself. I mean, clustering, if you can combine, I'm not sure whether you people are also aware of the reporting tools. So if you apply clustering as a machine learning technique, and if you parallelly you work with any of the data visualization tool, probably that will give you that will be beneficial for you guys. So going forward, for any kind of modeling, data visualization, that is one of the most important step. And another step, please make sure it doesn't matter, it is clustering, it is supervised, unsupervised, whatever it is, the learn what kind of technique you are applying, make sure data pre-processing, that is the most crucial step for any kind of machine learning algorithm. If you don't do the pre-processing in the right way, no matter how efficient your algorithm it is, how strong your algorithm it is, it will not give you right kind of result or output. Or even though it gives you some kind of output based on the test validation, but actually finally the accuracy will not be that much. I mean, the resultant will not be that much effective. That's what I can say. Okay, thank you guys.
Thank you for that brilliant session, Mr. Hazra. So I think we can wind up the session now. I thank the Department of Computer Science and Engineering, AI/ML, and Cybersecurity, and Futurance Technologies for organizing these Industry Connect sessions for our students. We are grateful to our resource person, Mr. Debasish Hazra, for accepting our invitation to interact with our students. Thanks are due to Dr. V. Vivek, the head of the Department of Computer Science and Engineering in Artificial Intelligence and Machine Learning and Cybersecurity, and all the faculty members for helping our students to attain the best in everything. Thank you, students, for participating in this Industry Connect session. We will meet you next week with another session of the Industry Connect program. So let's call it a day. Thank you and good night.
Thank you very much. Bye-bye.
Yeah.
Good night.
Yeah. Bye-bye. Participants, make sure you fill the survey form before you leave. How did you not get it, Aman? Did you just join the meeting?
Ma'am, due to connectivity issue, ma'am.
I shared it like 5 seconds ago.
Not that, ma'am. It's just my net went really low.
Okay, shared it again.
Thank you, ma'am.